All right. Hi everyone, this is Kushash Mali. Today in this video we are going to talk about how does an OpenCV function from C++, which is in the source code, go to the Python layer, which is essentially most of the people that use OpenCV are calling OpenCV module from Python. There are C++ and Java bindings as well. I mean, you can use it, but a lot of people, at least on the application side, are using OpenCV. So how come those 4,000 plus functions are actually written in C++ and are eventually relayed to Python layer? How does it all work? Back when I was graduating, I had a chance to try out OpenCV. It was one of the first libraries, actually, not even one of the first, it was the first library I tried. And I tried to play around. I used to blur images, I used to blur with different kernel sizes, try to form an animation out of it, give some demos to my juniors in the college. And one of the most important thing I think I did for my career was go and look at the source code. OpenCV source code is outstanding. First, because it's coming from 2003, 4, at least from that time to 2026. If you're watching it this year, these things are very interesting. How these principles have evolved and actually stayed as well, and how does it work? So we are going to talk about that now. Let's go ahead. All right, so let's start. I'm in OpenCV right now. I've cloned the repository, so let's hit the new Vim session. Now, for those people who are kind of used to it, they'll know what to search. But what I generally do is, of course, after going through all these source codes, I know that I can search for Gaussian blur, and this is how it will look like. For those people who are kind of not sure, they can also search for just this. Go to the quick fix list and try for all these methods. Then go to definition and look for this particular declaration, which is eventually what we landed to. The very interesting thing about this is there are a couple of things I want to point out. Again, for those who are not aware on how to use OpenCV, it's going to be something like this, where you have an image, you have a kernel size and other parameters, whatever you want to pass. But in Python, the output is actually returned to this blur object, right? But over here you see output array dst, and the return type is void, right? So it's it's not clear to, if it's not clear to you, I think in this video it's going to help you out. And the second thing that's very maybe new to all of us who are used to writing C++, but not really the style of OpenCV is CV exports W. If you go to the definition of CV exports W, you will understand that these macros are essentially not useful at all. They don't do anything. They are just they are just totally empty, and they have essentially nothing to say. There is no value to these macros in C++, at least. But there's a catch, right? And now's the catch, right? What happens is when you try to build OpenCV from source, right? Of course, when you try to build OpenCV, a shared library will be formed that when you import CV2, that shared library will be used to fetch whatever header files and everything that should be imported at the import time, right? Now, when you build OpenCV from source, there is a cmake list.txt file that decides what all header files you should look at to understand whatever functions that you have that you need to export to Python. Now, these header files can have some helper functions as well, right? In Python, I think we are all aware that there is a way that you can have defined something like private. It's inherently, it's quite obvious that you should not be calling it in your public APIs. But if you have a function that's particularly without any underscore, right, it just means that okay, people can import it and use it. It's more like a practice that we have been following. In another world, how does how does OpenCV automate it all, right? And these are the points where these macros come into place, right? Whatever you see right now, these all macros are essentially nothing to C++ compiler, but very important to a Python file we are going to talk about. So let's look at gen2.py. This is essentially, if you look at this particular folder, the top level folder, which is Python src2, there are quite a bit of files, and these are the magic files that do most of the logic in place here. So cv2.py is interesting, and the reason it's interesting is if you look at the, just one second, I think what we are looking forward to is, yeah, there you go, right? So this is the main function right over here. Now, this main function is doing a couple of things. Let's look at the arguments it's taking. It's taking a config path, generate a configuration file in .json format, refer to python wrapper generator.config for available configuration keys. We'll come to that later, but output dir, okay, I think we can skip this one. The next thing is it's trying to load a particular JSON file. After this is done, what it does is it passes this to generator.gen. Okay, so let's look at this config file in case the config path is not passed. They look at hdr parser.opencv hdr list. Let's go to definition for this. It's very interesting over here. As it's quite obvious, I mentioned that the list is only used for debugging. You will see all these header files that OpenCV at the build time for debugging purposes is looking at these files to find out the functions that should be exposed into the Python layer, right? And one of the files that we have talked about is img proc image processing.hpp, right? We have already covered it. That's where GaussianBlur sits, right? So let's look at this. Okay, so what it does, it picks up the config file, it goes to hdr parser .opencv hdr list. It has all the header files for the debugging purpose. Now it tries to generate. Let's look at generator, what it does, right? Now that's what it does. It calls, it creates a parser object, which makes sense. It creates a parser object by going to cpp header parser. So this one is very interesting. Now the file we are in right now is hdrparser.py. It's very interesting file. And the reason it's interesting is it's trying to do all these things with all the functions that you see, right? It's quite clear. Maybe I can possibly go for define function declaration, right? So what it does for each function declaration, this will be called, which is what it's doing. It parses the whole header file. It converts it into a format that can be eventually converted into a C++ code that is understandable by Python compiler, CPython. Okay, so it will be understandable in that format, and that's what it's trying to do. Parses the function or method declaration in the form that is available in the form. CV exports return type whatever you had, function name, arg type, arg name equal to default value, whatever, and that's it. Okay, and then have const and function body. So whatever the whatever function that you have in the header file that is of this format, it's going to parse this format and convert it into a this format. Okay, so you have a function name, in which case this will become Gaussian blur, right? Return value C type, which is basically a PyObject star here. I think this one is going to be mat over here, which is basically a mat is a data structure used in OpenCV for images, arrays, and all of that. List of modifier, list of arguments, all these things can be skipped for now. But original return type can be void and then docstring. Okay, we'll look at it, right? We'll try to understand what it really returns, but it's trying to do this. Very important is this one. If not CV exports as, CV exports W, and CV wrap in declaring decl stir, it's going to return. That means whatever function that does not have it, it's going to exit early return, right? It's going to do nothing for you. It's going to skip the function. So any function that does not have those headers with the wrap mode on, I think it should be by default true. So we are very clear that, okay, it just skips those functions. So it's very clear what it's trying to do. I don't want to go too much into detail on what it's trying to do, but there are some interesting things as CV wrap else. What it will do is, if you want to wrap a C++ function, whatever you have written into Python layer via a different name, you could do CV wrap else and then try to write into a separate name. I am not very sure. I'm not really understood all the macros because very honestly they're not very relevant to me at this point, but these things exist is more important. And at this point, if you see, what it's trying to do is trying to, for all these tokens that are available, it's trying to replace all of them with empty strings. And so that, because as I said, these are not relevant for the compiler, but when you parse the file, it's important for us to know which function to really export into Python layer and which one to skip, right? And that's how it does. Uh, these things are minor, okay? Don't worry too much about it. One thing that's probably going to be very interesting is the right part, right? So once this is done, right, you have parser, CPP header parser as an example. If you want to run it, what it will do is it will run the parser, it will print everything that's passed, it will print all the testing. It's only for debugging. I don't think that's really relevant. Now let's go back to something where, yeah, there you go, right? So we have the parser created over here. Now what happens next? You go through the parser, you parse each header file. Okay, that is done, right? We don't need to worry about all these things for now. This is okay. It looks at the class info. It's basically trying to create uh, a hierarchy. It's trying to understand which sits in which class. All of those things, right? Again, not very relevant here, but one thing that's going to be relevant is where is it writing all of this, right? Which is the output file that it's writing to, and the interesting thing is there you go. So whatever like typing stubs and all these things will be used and AST is reconstructed, that's possibly we could use by our LSP as well. But the main thing is it's trying to generate these by OpenCV generated include.h, funcs.h, right? So whatever functions that you saw are essentially going to be written in this by OpenCV generated funcs.h. Now let's go and look for this file. Uh, you are not going to find it right now, and the reason is because my git ignore is trying to ignore those files. So why not I do this? I why am I not able to? Yeah, there you go, right? So I'm able to do find and I can just do find. Yeah, there you go, right? And let's search for Gaussian blur. There you go, we found it. I think, yeah, okay, I was right with PyObject star at least over here. Yeah, there you go, right? This is the interesting part. What it's trying to do is it has defined that we have src, kernel size, sigma x, dst, sigma y, border type, hint, all these columns. I mean, all these arguments, keyword arguments or whatever that matters. But one interesting thing that you will notice over here is this thing. Now, what does this really mean, right? Like, what is it trying to do? So O stands for PyObject star, right? Whatever that can be converted into a PyObject pointer or type. And this means that anything after that is essentially optional. Okay. So that's important thing for you. So anything that comes after these three arguments, that means possibly these three, if I'm not wrong. Okay. After this, everything has a default. So where we will see after everything this is all of this is done. By the way, this is interesting, right? You must be asking me, Kush, why do you have a repetition of the code here? And the reason you have is because Gaussian blur can return a type of UMat and mat. What it does is it defines both of the overrides over here, and the way it does is it first tries to call in a particular override that, let's say, is trying to return mat object, right? In a world, imagine that this does not really work well. What happens after this is it's trying to call the second override. If that doesn't work as well, then it's trying to overload exception, whatever overloads you had, not override, I'm sorry, overload. So whatever overloads you had, it will raise an exception that I tried these many things that did not work, hence raising an exception, right? So whatever overloads you had is going to try in a no specific order, at least from what I understand, and then it's going to raise an exception. So far we have understood what it's trying to do, right? It's trying to write all these into a header file that's understandable by a Python compiler. See Python over here, PyObject star. It's trying to convert all the arguments that you receive from C++. I mean, when you receive something, it's going to be in the Python type. You have to convert it into a C++ understandable type. This is what it's trying to do here. PyOpenCV to save, I believe, is written in I I think, yeah, it should be in cv to convert.cpp. If you are curious about this, definitely go forward and give this a read. It's very interesting because what it's trying to do is trying to convert all the Python types into C++ types. As an example, you see that, okay, how do you convert mat? Right, this mat data structure exists in C++ source code. How do you convert this mat object into NumPy array? What allocators do they use? All of these things, by the way, are available in my blog as well, so you should definitely give it a read. But these things are very simple. You can possibly just give it a read, skim through these, and you will understand, okay, these NumPy types are basically mappable to these OpenCVD types as well, right? So that's what it's trying to do. It's trying to convert these arguments to and fro wherever needed. One very interesting thing before I log off from this video is error wrap to this macro. Okay, and okay, I don't know why it continues to not work. By the way, this is where you kind of see, okay, this is how they're writing the template. It's very interesting. But yeah, okay, my bad. Yep, there you go. Right, so this is how it's doing. It is a wrapper which basically unblocks the GIL, that means takes it away from Python, says that, okay, I'm allowed to use threads. Whenever I call my C++ function, any image processing library is going to be running heavily on threads. There are a lot of operations, there are a lot of numerical operations that any operation would like to do. And it's very important that you leverage threading over there. That's why you also, this is like a Python concept on how do you really unblock, like, I mean, take GIL away from Python compiler. That's how you do it. And there's one more interesting thing. Over here, you will see that it's trying to convert the CV exceptions into Python standard exceptions. Otherwise, I think these things will just fail. So it's important for you to, whenever you catch an exception that's of a C++ type, you have to convert into an exception type that C Python compiler will understand. Okay, sounds good. By the way, I think we got lucky that we came to this function. I'm going to talk about this in a separate video. I don't want to spoil the fun. But that's what it's doing. It's ensuring that you can use threads when you call this Gaussian blur function. And it's also ensuring that whatever exceptions it raises, it converts into a Python understandable, C Python understandable exceptions. And then it eventually calls Gaussian blur. We have already seen image proc.hpp. That's what it calls. Then whatever output you have in DST, it's trying to convert into a NumPy array object. That's it. Ta-da, done. I think for this video, this should be good enough. We do want to touch upon how all of this works in detail, especially the Mat and NumPy collaboration. How do they collaborate so well together? Something we'll touch upon in the next videos. For now, I think this should be enough. That's it for this video. If you like the content, do leave a comment down below. If you did not, let me know what I can improve. But I hope this gives you a good overview of OpenCV source code and gives you some motivation to go and read the source code as well. Make some efforts, try to contribute if you would want to. I love the library, do in good faith. Uh, that's it. Thank you so much. Bye bye.